Hey everybody, welcome back to the channel. So recently Neil from Essex did a video on tractor ballast, specifically advising customers about the difference between liquid ballast in the rear tires and then actual ballast on a 3-point hitch, which could be from a weight box like I have here, or from some sort of an implement like a box blade, a bush hog, or a backhoe. And it's a real great video. I'll put a link to it up here on top. But one of the things Neil missed at the very end, I think, was really one of the biggest factors when deciding between loading your rear tires or putting ballast on a 3-point hitch. And so I want to kind of get into that today. So if you want to stick around, we'll get started. Alright, so I did a video about a year ago talking about compact tractor operating tips and tricks, really to help you, operate your tractor safely and effectively. And I did cover ballast and balance in a section of that video, and today I really want to dive into that a little bit deeper, put more emphasis on that specific topic. So we're going to start out here with the tractor and talk through things out here, and then we'll switch gears, go inside, sit at the computer, and we'll look at the math and the physics behind this whole ballast and balance situation. It really shows things very clearly, very nicely, and lets us come up with a rule of thumb that we can understand and then use to better work out ballast for our tractor in different situations. So we'll start out here, and really it's a very simple situation with balance and ballast on tractors. In this configuration, we've got something heavy in the front loader. Okay, we've got two different balance points on the tractor about which the tractor is going to want to pivot. First, we've got our front axle with our front wheels and front tires, and then we've got our rear axle, rear wheels and rear tires. And then behind the tractor, we might have a weight box, an implement, a backhoe, something that's sitting behind the rear axle and putting load on the tractor back here. And so in the end, what we sort of have is a dueling situation where we've got this payload up here in the front loader that wants to tip the tractor this way, okay? And then we've got ballast back here behind the rear axle that wants to tip the tractor this way. And it's really the duel between those two loads that's going to determine your stability, your balance, and also your forces and stresses on your front and rear axles, okay? It's all comes down to the front payload and the rear ballast on the 3-point hitch. Now, you might be thinking, well, hey, what about my rear tires? Maybe I have liquid in my rear tires. Maybe I have weights attached to the rear wheels. Doesn't that create ballast? And the answer is yes, but not like you would think. And it's funny, but because we put this type of ballast directly over the axle line, directly over one of our pivot points that governs the overall balance of the tractor, all that weight's going to ever do is push this rear wheel into the ground with more force, okay? And in fact, if you've ballasted your tires or your wheels and you're keeping the rear tires in contact with the ground, and you have good traction and the back end's not bouncing around, this ballast has done its job, and that's about the most it's going to do for you. But unfortunately, when we're lifting heavy loads in the front loader, that creates a lot of stress on the front axle. And really what we want to get a benefit out of our balance is to take some of the load off the front axle, take some of the stress off of the front axle, the bearings, the wheels, because these really bear the brunt of the abuse when you're lifting something in the front loader. And unfortunately, liquid ballast in the tires, wheel weights, they will not help the front axle at all. And the easiest way to visualize that and think about it is, because we're adding this type of ballast directly over the axle line, which is one of our pivot points again on the tractor, because that force is pushing straight down here, it really has no leverage about this pivot point, okay? So we put the load, the ballast right here, it's not going to be able to affect the balance of the tractor at all. And so that's the important thing to realize with liquid in your rear tires or wheel weights. All they're ever going to do is they're going to push down this rear tire, keep it in contact with the ground, and give you better ground force and traction at the rear. Unfortunately, it's not going to do anything to help your front axle, which is really what we want when we're lifting something very heavy in the front loader. And the way to visualize that again is to go back here and think about, well, now I'm putting something heavy behind the rear axle. Guess what? This now has leverage. It has leverage to the rear axle, one of our balance points, and that's going to tip the tractor this way. And what is that going to do? It's going to take load off of the front axle. Okay, so really, this is the important distinction. I think this is what Neil missed emphasizing in his video. When you're talking about what's the difference between loading your tires and putting ballasts on the 3-point hitch behind the axle, well, the difference is that loading your tires or using wheel weights, that's really only going to help you keep contact and improve traction at the rear axle. It's not going to help you offload your front axle. You absolutely have to have your ballast back here behind the rear axle where it now has leverage if you want to take the load off your front axle. And so that's the most important thing. If I leave you with one concept in the whole video, it's that these two types of ballasts are not the same. They really have different purposes in the end. And so this is a good point to go inside. We're going to go on the computer, look through the physics and the math of this balance and ballast situation, and I think that'll make things a little bit clearer, and also we'll see some interesting things come out from that analysis.
All right, so we're inside sitting at the computer now, and we're going to kind of step through what's known as a statics analysis of the balance and ballast situation on a tractor. This is the same kind of analysis you'd use if you're designing structures, beams, really any other things where you want to look at the forces and the moments or the torques on a body that's in static equilibrium, which means it's not accelerating, it's either staying put or moving at a constant velocity. So on the top of this current screen, I've got a diagram of a tractor, and this kind of mimics my tractor setup. And I've sketched some of the relevant forces shown here, and let's just move from left to right. We've got a ballast box in the rear that's going to be pulling or creating a force downward. And by the way, since gravity acts vertically, all the forces here are vertical, keeps things simple. So we've got ballast on the back of the tractor. On the wheels, I've got a T to indicate tire weights. Could be liquid in the tires, could be wheel weights, but that's going to be given by T. And then we've got a ground reaction R on the rear wheel. In the middle of the tractor, we've got the weight of the tractor acting downward, and I've kind of indicated that's over the tractor's center of gravity. We know it's between the two wheels of the tractor. I don't know specifically where it is. I have a rough idea in my tractor, but it turns out that's not going to factor into the analysis at the end. It kind of goes away. And then on the front tire, front axle, we've got a ground force there given by F. And finally, all the way on the right, we've got the payload in the front loader given by the force P. And so those are all the forces acting on the tractor in this particular scenario shown in the top. On the bottom, I've really made a diagram of the equivalent beam. And I kind of inferred when we were talking about this out at the tractor, this is like a balance situation, a beam, a teeter-totter. It really is. You can really distill this down to forces acting on a beam that have two pivots or two balance points on the bottom, R and F, and then you've got these vertical forces acting downward on the top of the beam. And it's really as simple as that. Whether it's a tractor or beam, it's going to be the same type of forces acting on this object that puts it into balance, into equilibrium. One interesting thing we can kind of see directly here is that out at the tractor I mentioned how the ballast you put in the tires, whether it's liquid or wheel weights, that's acting directly over the ground reaction of the rear tire. It's not going to affect the overall balance. You can visualize this pretty clearly in this representation of a beam. I mean, this force, this tire ballast, these wheel weights, they're acting directly over this balance point. They're not going to do anything to affect the overall pivoting or balance of the beam because it's directly over one of these points. And so that kind of reinforces, what we mentioned is that, yeah, you can put ballast, liquid ballast in your tires. You can put wheel weights on. They will help push the rear tires down into the ground, but because it's directly over that balance point, it's not going to affect the pivoting or the overall balance of the tractor. So that's our first diagram, where I just wanted to relate what the tractor's doing and the forces on the tractor, what they're doing to a simple beam. And if we move over one, now we can get into the equations. And so this is where we get into the kind of the guts of the statics analysis. And really all you try and do is you're applying basically Newton's law that says, if this thing is not accelerating, then the sum of the forces have to equal 0. And then the sum of the torques, or what we call moments, they also have to add up to 0, okay? If this thing is in static equilibrium, then the forces and the moments have to add up to 0. And so we just go through these different equations here. First, I'm going to do sum of the forces, where I'm going to take up being positive. And so again, left to right, I got a minus B, I got a plus R, minus T, minus W, plus F, and a minus P. And for this to be in equilibrium, they all have to add up to 0. And then some of the moments, this is where you basically look at each force and you visualize its lever arm to some reference point. You can pick whatever point you want to be convenient. For the sake of this work, I'm just going to pick this imaginary center of gravity of the tractor as my pivot point to sum up my moments. And so I've got some of the dimensions down here shown for my particular tractor. And so this force acting downward, B, it's 71 inches from this center of gravity, so I got a minus 71B. And again, I'm taking clockwise to be positive here. This one is counterclockwise, so it's negative. And then 36 inches away from the pivot or the reference point here, I've got a T and R, opposite signs. I've got a F pushing up, turning that way, so that's minus, and that's 28 inches away. And then the payload in the front here pushing down, that's going to go clockwise, and that works out to be 100 inches from our reference point, so I've got 100p. And again, these all have to add up to 0 if this tractor is in equilibrium and it's not, accelerating rotationally. So this gives us two equations. We're going to assume we know a bunch of these letters. I know the weight of my ballast box, I know the weight of my payload, I know the total weight of my tractor. I have a pretty good idea of the weight of my liquid ballast in my tires. And that's going to let us solve for unknowns, which could be reaction forces on the ground. You could solve for a bunch of different things, but for this analysis, since I want to talk about the benefit and the impact of rear ballast on your front axle, I'm going to solve for F, okay? And so it's really just algebra combining these two equations. And if we go through the algebra, we come up with this equation for F shown down here, okay? And if you just look at this, it's saying the force acting on the front axle is a combination of the payload, it's a combination of the tractor weight, and these are both additive. They're increasing that force on the front axle, and then taking away from it is the effect of our ballast, B at the rear. Okay, so that's what we've got out of this equation for the front axle force. I want to go one step further, and I want to say, well, you know what? I'm really interested in the interaction between the payload and the ballast. The weight of the tractor is always there. I know that's always a effect on the front axle. I don't care about that since it's always there. I really want to look at the difference beyond that due to the interaction of the payload and the ballast. So I'm going to move that weight term over to the left-hand side of the equation, and I'm basically now looking at the difference or the effect of the payload and the ballast working against each other. They're kind of dueling against each other, and I'm just going to call that delta F. That's the change in the force on my front axle due to payload in the front loader and then offset by ballast at the rear. Okay, and so that's our equation for my specific tractor with my specific dimensions. We haven't plugged in any numbers for payload or ballast yet. There's a bunch of these variables here that we don't know, we haven't solved for, but they don't come into this final equation. We really show that the change in force on our front axle is only due to this balance between these two terms. One is with the payload, the other is with the ballast, and that's it. That's as simple as it gets. And I want to mention one thing, one interesting thing here. Look at what is not in our equation, okay? What is not in our equation is anything having to do with our tire ballast, T. Whether it's from liquid or wheel weights, that term T is gone, okay? And again, we talked about this at the tractor, and we talked about it looking at the beam in the previous chart. You know, when this is right over one of your balance points, it can't really affect the overall what's going on at the front axle, okay? It's just going to push the rear tire down, and sure enough, you go through the analysis, you go through the math, we get to our effect on the front axle, T is nowhere to be found. And so this is kind of, you know, the mathematical and physical reinforcement of what we can visualize, and it's telling us, yeah, you can ballast your tires, but that's going to have no effect at all on the load on your front axle. And so it's nice to see that come out of the wash in the math. I always love it when you can take, you know, multiple methods and drive to the same conclusion, whether you're standing out there looking at the tractor and waving your hands, or you're going through the analysis, coming up with an equation. This really confirms, hey, whatever you do to the tires, to the rear axle as far as ballast, it's not going to help your front axle at all. What affects the front axle is going to be this overall balance between the payload and the front loader and any ballast you have behind the rear axle. Okay, so that's our equation. And if we want to generalize this, and again, when I went through this the first time, I had all kinds of extra variables for lengths and dimensions, and to me it confuses things. And so I started here with, you know, dimensions specific to my tractor. You see these inch dimensions between the different forces and parts of the tractor. And we come up, you know, with this equation that has numbers in it. To me, that's just quicker to get to when I'm trying to explain something. If we want to generalize this though, then we can go to this next chart here. And so I've got this tractor, I've got our equation, and now I've written the equation only in terms of the ballast, the payload, and these generic lengths. First one is over here, the length between the ballast and the rear axle. The second one is really your wheelbase, your length between the rear axle and the front axle. And then the final length is the distance between the front axle and the payload. Those are all different lengths. I've put them in here in these different terms. And so this is the general form of the front axle loading equation for a tractor. This applies to any tractor, not just my tractor. You can plug in dimensions for your tractor. If you know how much payload you're putting in on the front loader, you know how much ballast you've got in the back, and the distance from the ballast to the rear axle, the payload to the front axle, and the wheelbase, you can determine the additional force and loading that's going to be on your front axle. So this is a nice simple equation. You can look through this in any situation and come up with some estimates and you know, use this to maybe be a little bit friendlier to your front axle. If you know you're going to lift something heavy in the front, you know, you can work out, hey, this is how much ballast I should have in the rear. This is how far back I should have it. You know, you might decide, well, maybe I'll use a box blade, but no, maybe I want something that hangs out farther. So I'll put the bush hog on instead, because it's going to stick out longer. It's going to make this length bigger. It's going to amplify the effect of the ballast. It's going to give it more leverage. So you can work through this equation and talk about the ballast on your tractor in terms of the effect on your front axle. And I wanted to take this equation and just give some examples. And so the last chart we're going to go through here are three different examples. The first one, I've got a payload of 1,500 pounds in the front loader. I've got no ballast on the back, so I show that here, but I'm setting it to 0. And then these are the lengths that apply to my tractor. And so when I put 1,500 pounds in the front loader, that ends up putting an additional 3,188 pounds on the front axle. And you might think, hey, how's that possible? You're putting 1,500 pounds on the front loader. How do you get another, you know, almost 3,200 pounds on your front axle? Well, you know, this is cantilevered over that front axle. That amplifies the effect dramatically. And we're seeing that here. You lift 1,500 pounds, with no ballast on the rear of the tractor, B is 0, you end up putting another 3,188 pounds load on your front axle, okay? So that's our no ballast example. Number 2 in the middle here, same 1,500 pound payload, but now I've got a ballast box on the back, and this is the weight of my ballast box. It's right around 1,000 pounds. Again, these dimensions apply to my tractor. When I lift in this scenario with the ballast back here, the change in force on the front axle is now 2,641 pounds. And so that is down from 3,188, okay? And that's the result of us putting ballast on the back of the tractor. It really does relieve the load on the front axle. And that's what we're trying to do here. That's the whole point of ballast when you're lifting with the front loader. You want your rear ballast to make life easier on your front axle so that it's not carrying this huge amplified effect that you get without ballast. Okay, so we've got a nice benefit here, about a 500 pound reduction in the load on the front axle. And then let's go to example 3. Let's say, well, I really want some better ballast, and so I'm going to put a bush hog on my 3-point hitch. Okay, that bumps my ballast up just a little bit to 1,100 pounds, but that bush hog hangs out so far back behind the tractor that my ballast length now goes up from 35 inches to 82 inches, which is huge. And when we do that, we end up dropping the load on the front axle down to 1,778 pounds. Okay, so you can see this progression: no ballast, ballast box close to the tractor, and then using a long bush hog as ballast behind the tractor. We see a big reduction each time, and in fact, you know, this one, you know, we're about what, about 900 pound reduction, give or take, just by putting the bush hog back there, getting that ballast hanging out far behind the tractor. And so these are some nice examples using that general equation you have here. Again, very simple equation. You just need to know some dimensions of your tractor. You need to know your payload you're lifting in the front loader, and then the ballast weight and where it's located in the rear. And you can go through and work up some examples like this. You can really, you know, plan things out for your tractor. But I think more importantly, even if you're just doing this for learning purposes, look at the difference between no ballast, close-in ballast, and ballast that's hanging way out the back like a bush hog. That's a big difference going across these 3 examples. And that provides a dramatic reduction in the load on your front axle. I mean, it's almost half here compared to no ballast, not quite half, but it's close, and that's a big reduction. So that's kind of one of what we want to emphasize here with the equations. And again, you know, we talked about this out at the tractor. This is kind of the mathematical physics of the problem. It's really a simple beam, even though it looks like a tractor, and we get some nice results here that kind of reinforce what we talked about out there. So that's going to wrap up things here on the computer. Let's go back outside and make some final comments.
All right, so hopefully this has been useful. And again, the main point, if you want to offset the effect of your front payload on your front axle, you absolutely need to have your ballast behind the rear axle. So that could be something hanging on the 3-point hitch. It could be a backhoe. Whatever it is, it absolutely has to be behind the rear axle, so it gets behind this pivot point, this balance point, has leverage, and can take the load off the front axle. Okay, so that's the thing to remember here. I guess one last question, you might be wondering, well, what the heck is the point of ballasting my rear tires or putting in wheel weights? Well, again, that's going to help keep your tractor stable. It's going to help keep your rear wheels in contact with the ground. If you've ever operated a tractor without loaded rear tires and you're driving around with a front loader on, you'll notice the back end's real bouncy. Well, when you ballast your tires, it's really going to help keep them in contact with the ground. It's going to give you a smoother ride. It's going to be more stable. And so there is a purpose and a point to ballasting the rear axle, the rear tires, putting liquid in your tires. And that's really just stability and basic neutral balance of the tractor as configured with the loader before you put the payload in the front. Okay, it's when you add that payload, you now have to think about putting your ballast further back behind that rear axle. So I think that's going to wrap things up for today. I hope this was interesting. I hope it was useful. As always, if you have any questions or comments, leave them below, and thanks for watching.